Hey students, this is section Appendix O, the complex numbers, and yeah, in this section we're basically talking about imaginary values, and yeah, a lot of the rules, not all of them, but a lot of the rules for imaginary values, and there are a few sections to cover, so we might move quickly. However, I think the rules are simple because you can treat an imaginary value or of the I value, okay, this one, and let me go ahead and expand the screen here really quick so you can see better. There you go. And imaginary numbers like I, for example, you can treat that as a variable. You can treat it as a variable, and therefore you can perform any operations to it like you would a variable. There's a very minor difference when you have i's or imaginary values inside a radical, and I will go over that when we come across it. But that's gonna be the only difference where you do not work an I value as a variable, and I will show you why and how. And it's you should still treat it as a variable. However, it's not easy to see when you have a negative value. See, when you have a negative value inside a radical and you try to multiply, but then you need to get that I out of there first before you multiply. See, because when you're working with radicals, when you're working with square roots, when you multiply them, the rule is to multiply the radicands, right? However, if you have two negatives, you can't do that. Okay, first you're gonna have to get the negative sign or the I outside of the radical signs, okay, and then you multiply. But you're basically treating it as a variable, okay. So yeah, just think about treating I as any other variable, okay, and you should be able to add, subtract, multiply to it, use the rule for exponents and everything, okay, just as you would a variable. Okay, so let's move on to the first example there. They are asking us to express in terms of I. In other words, see, like I said, whenever you're working with square roots, radicals, you cannot have a negative value inside because there are no square roots, negative square roots. There are no square root values like this, a square root of -7. It just doesn't exist because it's because the if you square, let me get a piece of paper. Let's see, where was I? I was right here. Because, and I explained this before, because if you square a value, well, any value square, any value square is gonna give you, even if it is negative, yeah, even value square, it's gonna give you a positive answer. See, so you cannot get a square root, a negative square root. Yeah, cannot get a negative square root value If you think about it, I don't know if that explains it well, but see, because if you raise this negative 2 to a positive value of 2, positive exponent of 2, then you get a positive 4. Same for a positive value, you still get a positive answer. So therefore you cannot have negative values. We cannot have negative values inside radicals. Therefore we need to treat them differently, okay? And for that we need to learn this rule here. And I say this rule because it's only one. To me it's only one, because if you can remember this portion right here, you can figure this out. See, because if you are here at I squared equals negative 1, then what happens if I square both sides? See, if I square both sides, this I is gonna come outside as I equals, and then this stays as negative 1. See, and this gives me this right here, okay? Just by thinking about this portion here. And the second thing I would memorize this part here instead of that is because we use this part a lot. I mean a lot. Way more than this, okay? And so memorize this part. Memorize I squared equals negative 1. And there are parts of the book that explain that, and parts of other algebra books that explain why that is, okay, why we choose I and I squared and all that stuff. However, you don't need to know that. If you want to read about it, that's fine. Go ahead and do it. Here, for this class, all you have to memorize, basically, about imaginary complex numbers is that I squared equals negative 1. Okay, I squared equals negative 1. I squared equals negative 1. That's it. Okay, and then just again apply the rules for that you would use in any variable, right? So if you already memorize that I squared equals negative 1, then you can see that we can express this in terms of I, because I know what I means now. That's my imaginary number. That is my imaginary value, and it means square root of negative 1, right? Square root of negative 1 for any negative values inside the radical signs. That means there is a factor of negative 1. Okay, so if I know that means this, then I can get rid of the negative sign by getting an I outside of the radical sign. Okay? And you can also think about it as, for that, and I think this is easier. I think this, you can see it better because you are used to having perfect squares inside the radical sign. Okay, so negative 7, square root of negative 7, you can rewrite it as the square root of I squared, since we said, well, let me expand it even further. Okay, negative 1 times 7. So this means the same thing. A negative and a positive gives you a negative. Okay, we can also rewrite it as let me see, negative 7, negative 1, negative 1 times square root of negative 7, right? Well, yeah, because in this case, if we multiply, All right. And we know that this means this, right? We can rewrite it as I times square root of 7. Okay, so or I square root of 7. And you're probably more familiar with this setup right here. Okay, so yeah, because the book shows you that you can also write it as square root of 7i. Okay, however, I wouldn't do that because you can't really tell that this I is outside the radical sign there. So I will write it like this instead. Okay. All right. And from here, you can also think of this negative 1, square root of negative 1 as being square root of I squared. Remember, I told you to memorize that. I squared means negative 1. I squared equals negative 1. Negative 1 means I squared. So you can do that too. All right. And from there, you can multiply times 7. I squared, since it is over 2, you can bring it outside the radical sign there. Square root of 7. You can also go from here to I squared, writing it as I squared times 7. See? Now I can factor this I out. I mean, I can get the square root of that and move it outside. Yeah. So this led me to this way, led me to this. From here to here, led me to this. From here to here, it led me to this. So 3 different ways of thinking about it. They all are going to lead you to the same thing, okay? But as long as you can remember that I squared means negative 1, you're going to be skipping steps in no time, okay? For this kind of value here, negative square root of negative 13, just get the square root of negative 13 first, and then add the negative sign at the end, okay? Yeah, don't forget to add this sign at the end, because you didn't do anything to it. Yeah, you didn't do anything with it. Again, I square means negative 1. Well, factor out a negative 1 out of that negative 13, right? And then write it equal I squared, and then move it outside, okay? For this kind of problem here, you're gonna have to be careful because you need to simplify as much as you can, okay? Because once you get that that I outside the radical sign, then you still need to simplify. You need to simplify as much as you can. Here we stop here because these are prime numbers. Here this is not a prime number, okay? Therefore you need to simplify as much as you can. Let's see, 48. Yeah, 48 is not a prime number either, and therefore you need to simplify as much as you can. In this case, 48 is not a perfect square like 64 was. Therefore, you need to separate. Yeah, you need to find the factors of 48 and get the perfect squares, any perfect squares, outside of the radical sign, okay? And now this is the simplified version, okay? Well, this right here. Don't use that. Use this form instead. Okay? And moving on. What else? Complex number from the system of complex number. No. No, that. Let's. Yeah, that was section A. And then moving on to B. Yeah, objective B. and it is about addition and subtraction whenever you have complex numbers. Oh yeah, and if you can memorize this term here, complex numbers, complex number system, or the complex number, imaginary numbers. Well, you probably already knew this word, imaginary numbers. If not, yeah, that's because of the I. If but this, if you can remember this, that would be nice. Whenever you use complex numbers, I mean imaginary numbers, you're using the complex number system. Okay, that would be nice to know. I'm not gonna test you on it, but that would be nice to know. Add or subtract, yeah, addition or subtraction. Whenever you have complex numbers. In this case, again, I told you to treat it as though it was a variable, the I, just any variable. Use the operations, you know, the rules for everything. That if you use it with a variable, you should be able to use it with this I. Okay, so in this case we're adding. Okay, we're adding. And I'm just rewriting this over here. A plus 6i plus 3 plus 2i. Again, just treat it as any other variable. Here we are adding, therefore we don't need the parentheses, okay? Because these are all positive, okay? So I'm just gonna rewrite everything in one line and without parentheses, okay? And then now I can see that I need to combine like terms, okay? Again, treat it just like that you would any other variable. Here I have constants and I have variables. Well, my imaginary values there. 6 plus 2 is 8. See, you treat it just like it was a variable, another variable. 8i, okay. I'm done with those two. Now my constants, put them together. That's 11. The simplified version of this, well, the addition was this. Okay, and we're done. Okay. And they wrote it as 11 plus 8i. I don't think you have to. Since I'm used to writing my variables first, that's what I did here. So you're good. Okay, so what about 3 plus 2i minus 5 minus 2i? Well, in this case, we are subtracting. We're not multiplying either. Okay, we are subtracting. So since all of these are not positive signs, positive values, positive terms, we need to go ahead and work on that. See, because this negative sign affects this parenthesis here, and this parenthesis has two different terms. Therefore, this negative sign affects both of this. So I'm just going to rewrite the right part here there, because that negative sign doesn't affect that. Negative times a positive gives me a negative 5. Negative times a negative gives me a positive 2i. And I got rid of the parentheses. Now I can see that I can combine like terms just like you would any other variable. I'm going to combine the two i's together, and that's 2 plus 2, that's 4i. And I'm done with those. Put my constants together, that's negative 2, and I'm done. Okay, that's the simplified version of that, and that's what they got, that's what we got, except for I wrote it and I wrote the i's first. Okay, and there's nothing to addition or subtraction of complex numbers because you treat them as you would any other variable. Okay, so we need to move on. Multiplication. Now we're multiplying. Okay, so this is why I told you that the rule changes just a little bit, not much, because remember that whenever, and I'm just gonna rewrite it here, -2 times the rule for multiplication square roots was to simply multiply the radicands, right? Here you'd be tempted to go like, well, that would be negative and a negative times a negative gives me a positive. That's a positive 10, right? Well, you'd be wrong because remember that we don't have any negative square roots, no negative square roots. You can get a square negative square root values of square negative square root values. So so we can have negative signs inside the radical there. Therefore you need to get rid of the negative signs first before you can apply that rule for multiplying square roots. Okay. So before you multiply them, get those negative signs outside the radical by well, let me rewrite this as I squared, because I think I like this, writing this way better, times 2, because I'm familiar with getting a variable squared inside and then just moving it outside. So I'm just rewriting it as I squared to this -1 becomes I squared, right? Because I squared equals -1, okay? Times 5, okay? And now I'm ready to simplify because I know I can move this I outside the radical sign, rewrite that 2 times, oops, I times I times 5, square root of 5. Okay, so now I can apply the rule for multiplying square roots, because notice that I have positive values inside the radical signs. Okay, I times I is I squared. Again, you treat it just like you would any other variable. I times I, you multiply in there, just multiplying, since you have like bases and you multiply, just add the exponents, that's 2. And then for the square roots, square root of 2 times square root of 5, just use that rule, you multiply the radicands, and that's it. If you can simplify here, that would be nice. Well, actually that would be correct. However, the only factors of 10, well, the only prime factors of 10 would be 2 and 5. We cannot get perfect squares from that. So that should be the simplified version there. Okay. And let's see what else. Oh, no, we're not done yet. No, we are not done. See this trick me right here, because and this should yeah, it is a pitfall, but you shouldn't get tricked by this, because once you get an I square, you need to always simplify it as -1. Okay, so then that will become a negative square root of 10. Okay, so then don't let this trick you like it did me. Okay, and it does trick me from time to time, because you're working with one I and you work with one I the whole way, and then at the end you get an I squared. See what I'm saying? And that's it probably doesn't trick you, but it slips by. See, that's what it did to me. It just slipped by, and then they know that was an I squared. But if it is, you need to change it into a -1. So -1 times square root of 10, it's just negative square root of 10. Okay, so that should be your answer. All right. Moving on to example. Well, to page 1226. Okay, so that's example 1226. We will multiply. Okay, multiply again, and I'm just gonna work out one of these because just to show you the rule. Okay, again, this is the way I would work it. Okay, since I know I have a negative radicand, well, two negative radicands. Remember that we don't want that if before we multiply. No, we need to get those negative signs out of the radicals. And in this case, I'm just going to leave 49 as 49. I know that's perfect square, but I'm just going to leave it there for now. Times I squared 16. And I do this step just to show you that this I squared gets rid of the negative signs, okay, inside the radicals. Yeah. Now I squared moves outside, right? It's right in there. And then for 49, my perfect square is 7 squared. Okay. So multiply that times I. This I comes outside times 4 squared, right? Yeah. Just keep going because I know that these are perfect squares. They come outside. So 7, that becomes 7i. Oh, I'm done. It becomes 7i, and this becomes a multiplication of 4i. Okay. So now we're multiplying these two together. Okay. Again, treat them as you would any other variable. 7 times 4. We're multiplying constants here first. 7 times 4 is 28. I times I is I squared. Again, we went from having i's to the power of 1 to I squared. Okay. What does I squared mean? Well, it means -1, and that's the simplified version of I squared. Okay. And since we're multiplying, go ahead and multiply. 28 times -1, that's -28. Okay. So the answer will be -28, okay, which is what they got. Okay. And let me work out just one more, just set you up for the harder problems, I suppose, for the longer problems, not harder, but longer. Oops, I'm not showing you there. There it is. That's 1 plus 2i. See, because more than likely we're gonna end up with I squared somewhere. So I'm just gonna show you that you need to be well, you need to be ready for whenever that happens. Okay, because notice that we are starting with i's to the power of 1. Well, if I multiply, since these are two terms in two different factors, I need to multiply this 1 times all of these terms. So 1 times 1 is 1. 1 times positive 3i is 3i. And then multiply the second term times all these other terms. So that's positive 2i times 1 is 2i. Positive 2i times positive 3i is positive 6i squared. See, right there, that just happened right there, that I square, and I know that it changed there, so I'm aware of that, so that's good. Okay, however, let's see if it doesn't change. Hold on, because I might need to factor. Okay, let's see if let's see what happens here. Well, these are like terms, so I need to add them together. So that's 3i plus 2i, that's 5i. Rewrite everything else. Now this is looking like an equation, like an expression that I can factor right here. So what happens if I write it? And I don't know if I need to factor or not. So but that's something I need to find out. Okay, and this is the way you need to approach it too. Okay. I'm gonna write it in descending order because I'm used to factoring expressions like this. Okay, so this is the same thing as this, except I wrote it differently. Okay, so let's see if I can factor that. The only one of the options I can, one of the methods I can use is the AC method, because I have a factor of 6 here instead of 1. So I multiply 6 times 1 is 6. I keep that in mind somewhere over here. Okay, I'll just write it somewhere over there, far away from here, because now I need a value that will add up to well, 2 factors that multiply out to 6 and add up to 5. So 6 times I don't think that's going to be possible. Hold on. No, that's because I need 2 positives, and then if I multiply 3 times 2, yeah, 3 times 2. 3 times 2 is 6. When added together, it's going to give me 5. So that I use to split up the middle term. Okay, whenever you're using the AC method, you split up the middle term. Okay, split up the middle term as plus 3i plus 2i. Then just write this last term here, and you still have your same expression, except for you split up the middle term. See, because if you add them up, you still get the middle term. Okay, so now I'm ready to group. The best way to do it is by going like this and adding a plus sign in between those 2 terms always. Okay, even if you have a negative sign here, doesn't matter. It would be nice, it would be good practice if you split them up by with a positive sign there and not a negative sign. Alright, so now I'm here. Now I'm just gonna bring it up here and continue over here, because now I can see that that these 2 terms have common factors, not this. So 6i squared plus 3i becomes 3i times 2i plus 1. Okay, I'm gonna rewrite this part here. Plus 2i plus 1. All right. See, now I have 2 terms, 2 different terms. I can see that they have common factors. Well, this would be the factor, and 1, you can think of 1 as being the other factor. So yeah, so this is a factor, the whole thing. And I can factor them out. 2i plus 1, yeah. 12 plus 1, I'm done with those factors. And since these are called factors, I have to end up with 2 factors, okay? So don't write a positive sign here, that will be wrong. I haven't done anything to that 3i yet, so I rewrite it. The operation is addition times that other factor that was there, the factor 1, and I'm here, okay? And well, in this case, let me see, did we write it together? No. Okay, so in this case we didn't have to go all the way here, okay, because once we get here, here, we can simplify that. See, because they got to this part here, and then from here they just simplify it, okay? So because you have an I squared there, make it into a -1. Negative 1 times 6 is -6. Combine I terms, and you get to this here, okay? And this version is even more simplified than this, because you substituted a -1 for the I squared here first. So once you see an I squared, change it for -1, okay? Once you see an I squared, change it, substitute for -1, and that should simplify it. That should make your expression a lot simpler, even a lot simpler than this, okay? All right, I guess we'll keep that in mind. All right, moving on. Powers of I. Powers of I. What does that mean? Well, it means that since I squared means -1, then whenever you have powers of positive powers, you either get a -1 or a +1, okay? You get -1 or a +1, and that depends on this step, okay? Whenever you have odd exponents, you either get a negative or a positive y, or I, negative or a positive I, okay? Okay, so again, whenever you have even exponents, you get a negative or a +1. Whenever you have odd exponents, you get a negative or a positive I, okay? It all depends on this step here. Let's see if we can break it down even farther. It would be nice if we did. Okay, so think about it. You have I squared here. So when you have even exponents, your answer is going to be -1. So if you have 2 even exponents, then you doesn't it stand to reason that you multiply negative times a negative, that just give you positive. And then if you have 3 exponents, you multiply a negative times a negative, that's a positive times a negative, you get a negative answer. That might help. Okay? Whenever you have odd values, though, it's a little bit different. Well, the exponent thing still applies. However, you end up with an I because you wanna split up well, factor an I out of the I cubed, because you want even exponents, okay? So you're always going to end up with a residue of 1i whenever you have odd exponents, okay? So for example here, I'm going to have a residue of I here. That's what I call it, because I squared times I means I cubed, right? And we want to have even exponents. In that way we can turn it into a negative value, a negative 1. Yeah, negative 1. Negative 1 times I, negative 1 times I becomes negative I. And that's where the negative comes from the values of even exponents. And how do we say we get negative values of even exponents? Even exponents. We get the negative values by thinking about how many powers of 2. How many powers of 2 can I get out of the even exponents? In this case, we only could get 1, so that's negative 1. In this case, we got 2 of them. Negative 1 times a negative 1 gives you a positive 1. That's why we get a positive answer. Okay. So in this case, we only got 1 I squared. Therefore, we only have one negative 1. So we just multiply that times that's I. Here we have we start with an odd exponent. Again, you're gonna have always gonna have a residue of I at the end. So just think about the even exponents, and then think about the rule. I got two negative i's out of there. Negative I times a negative I is positive. Okay, that's why this I is gonna be positive at the end. Okay. That's one way of thinking about it. Okay, if you can remember that, that would be awesome. If not, that's okay. Don't worry about it. Because you can work it out like this. Okay, you can work this out if you can remember that. Okay, so here again we still have odd values of odd exponents, even exponents. Again, what was the rule for even exponents? Well, in this case it's not so simple to see, because what we want to do is get an I squared as the square root, because we want to turn that into a negative 1. Because if we can do that, that raise a 1 or a negative 1 or a positive 1 raised to any value can be that can be done easily. Yeah, you can figure that out very easily. In this case, I know that a negative 1 raised to an odd exponent is going to give me a negative 1. Okay, so the trick is right here. Okay, this here it's easy to understand, easy to do, this step. So don't worry too much about this step here, worry about this step here. So when we have even values, get the square root equal to I squared first. Okay, notice that all you're doing here is just halving it, halving the 58, because I mean the 58, because 29 times 2 is 58. Okay, so 29 and then 29 becomes the exponent of the exponent. Okay, and so now 29 is outside. Just think about that. You know that inside you're going to get a negative value. A negative value raised to an odd value, an odd exponent. Well, that's going to give you a negative answer, a negative 1. Since I squared became a negative 1, your answer should be negative, and it should be a 1. All right, so that happens when you have even exponent. Let's go to the next even exponent here. Again, we said that we wanted square root of I squared, because if we can do that, we can turn that into a negative 1, and then think about the exponent. Is it even or is it odd? If it is even, I'm going to get a positive answer. If it is odd, I'm going to get a negative answer. Okay, in this case, the exponent was 40, because that's half of 80, because 40 times 2 is 80. Okay, so I know that my exponent is going to be even, it's going to be 40, and it's going to be even. And inside I'm going to have a negative 1, and the square root is going to have a negative 1 raised to the positive 40. Well, any value, even positive or negative, raised to an even exponent, is going to be positive. So the answer should be a positive 1. Okay. All right, but what happens if we have an odd number, an odd exponent? Well, again, we said that we are always going to have a residue of I for odd exponents. Okay, and that's going to turn that into an even exponent, the I into an even exponent. In this case, it's 36. Now that we have an even exponent, we'll apply this rule. Just apply this rule, and you know that you're gonna want an I squared for the square root, and then half the exponent, and that should be your exponent on the new expression there. And from here, just think about your exponents as being odd or even. If they're even, your answer is going to be positive. If they're odd, your answer should be negative, because you're always going to get a negative 1 out of the I square. Okay, so in this case it's positive, your answer should be positive. Well, in this case we got a positive 1 from here times I. Positive 1 times I is just I. Okay, again, for odd values, you're going to have a remainder of I. Write the other I in even exponents as even exponents. Therefore, now you can use this rule. Get a square root of I squared, half the exponent, raise it to that exponent. If it is even or odd, just think about the rules of multiplication, by negative signs. Yeah, since you're always going to have a negative sign in here, if I raise it to an odd value, an odd exponent, I'm going to get a negative value, so a negative 1. Negative 1 times I is just negative I. Okay, so that's the rule there. And you don't have to memorize it. I might or might not give you any of these problems, because we are not going to get these big values with this kind of problems. I'm just giving you these rules unless in case you come up with big values like this, like big exponents. But if not, you should be able to use these rules here, or think about the I as being I squared being as a negative 1, which is what we've been doing so far. Okay, and I don't think well, see, the thing is that it depends on the book, what kind of values it gives you, because remember that the software gives you numbers at random. See, I tell it to give you some kind of problems like this, but then it decides which values to give you. So I don't know, it might give you big values like this. Okay, but if you do and you can't remember the rules, think about the rule I squared equals negative 1. Okay, you should be able to answer any question. just with that information right there. Okay, so we move on to objective E. Objective E talks about conjugates and division. Why are these together? Well, because we're gonna be working with rational expressions. That means expression like this. So that right there. Radical expressions. And in math, we don't want an I in the denominator. Okay, just like square roots, we don't want i's in the denominators. Okay, so simplify that. We simplify that by multiplying times its conjugate. Okay, multiplying times its conjugate because if you multiply times its conjugate, the middle terms go away. Okay, see, you end up with the first term and the last term. Okay, and that only happens when you change the second sign. Okay, so you're here. Okay, and we will be rationalizing here. So we need to multiply times the conjugate of 4 plus 3i. What is the conjugate of 4 plus 3i? Well, you only change the second sign. So the conjugate will be 4 minus 3i. Okay. So yeah, 4 minus 3i, and that's gonna get rid of the middle signs. Okay. See, once you get rid of the middle signs, you end up with an I squared. And what did we say you need to do whenever you get an I squared? Go ahead and turn it into a negative one. Yeah, that's going to simplify the expression even faster. Yeah. See, now we get rid of all the i's. See, at the bottom there. So we have efficiently rationalized this fraction here. Okay, and these are examples of conjugates. Okay, so like I said, only change the second sign. If you change the first sign, you're gonna get the wrong answer. Okay, so just change the second sign. So the conjugate of 5 plus 7i is 5 positive 5 minus 7i. Okay, so the 5 stays positive. See, the conjugate of negative 3 minus 9i is negative 3 plus 9i. Notice how the first sign stays the same. Okay, first sign stays the same, only the second sign changes. Okay, now here's a variation of that. For I, and the conjugate of that is negative 4i. And let's see. I don't think we're going to need it. I don't think we're going to need to know that for this problems, unless I mean, I didn't see one in the examples, so you don't need to know that. But if you can remember it, that would be nice. We might see it in the examples, but let's go ahead and work out these two examples here. So we need to multiply. And in this case, okay, so in this case they're just practicing multiplying conjugates. See this 5 plus 7i, the conjugate of that is this. Okay, so multiply as you would any other terms, you know. In this case we multiply 5 times all these terms, so 5 times 5 is 25. 5 times negative 7i is negative 35i. But the 7i times 5 is positive 35i, and then 7i times negative 7i is negative and positive negative. Yeah, that's gonna give me a negative, positive, negative, gives me a negative. 17 times 49 I squared. Okay, notice here how this cancel out, which is what we wanted, because we don't want these i's in there. Okay, and then for the 49i, again, as soon as you get an I square, think of it as a negative 1. Negative 1 times 49, negative 49, that's a positive 49. Rewrite 25 from here, add them together, and that should give us 74. Yeah, 74 right there. I'm not gonna work this one out because I want to work out the real deal here. All right. So, all right. Let's go ahead. Oh, we are here. We are not multiplying. We are just dividing, okay, and simplifying into this form. Okay. We are dividing and simplifying. So let's see. Again, I'm simplifying. If I'm simplifying this fraction, I don't want i's in the denominator. That's why I need to multiply times. And I'm just going to rewrite the fraction here. And then from here, I need to multiply times, well, I need to multiply times a 1 in the form of the conjugate of this expression here, which is 4. Again, only the second sign changes, not the first. Okay, so that's 4 minus 3i. That's the conjugate of this. Okay. All right. So now I'm ready to multiply. I'm gonna go ahead and multiply the whole thing, like 4 times 4. 6 is 16, and 4 times negative 3i, just so I can show you that the middle terms cancel out. And then positive 3i times 4 is positive 12i. And then last terms, negative and positive, is going to give me negative 9i squared. Oops. Okay, so again, all I did was multiply this, or FOIL it, as you guys call it, some of you anyway. And see how this cancels. These two terms cancel out. Rewrite everything else, except for now you have a negative 1 here. Substitute a negative 1 for the I squared. Negative 1 times a negative 9 is a positive 9. Okay, now you're here. Well, I'm just going to go ahead and add them up. That's 25. And then the same thing to this expression here. Multiply 3 times 4 is 12. 3 times negative 3i is negative 9i. Yeah, 9i. Positive 5i times 4. It's 20i. Let's see, positive 20i. And then for the last terms, I get a negative 15i squared. Okay. In this case, we need to combine like terms. So these two, a negative 9i plus a 20i is 11i, and it's positive. Rewrite the 12, and this negative 15i squared becomes positive. because I squared is negative 1 times negative 15 is positive 15. Okay, combine like terms, that's 27 plus 11i. So that's my new numerator. Okay, so the expression is 27 plus, if we did everything correctly, okay, over 25. Okay. You would simplify here if you could, but you can't, because 25 can be divided by 5, but not 27 or 11. Okay. So where are we? We are here. So yeah, we did get the answer. Except for they separated the expression into two fractions. Yeah, like I said, I mean, we would if they could be simplified, but this is still the right answer. Okay. All right, moving on. And I'm on page 1228 now, and I'm gonna skip solutions, well, section F, well, objective A, actually, because this is way too simple. All it is substituting to the equation for the value they give you, determine whether 1 plus I is a solution in the equation. Well, yeah, all you have to do is plug in the values in there, perform the operations, do multiplication, addition, exponents, and everything. Just use the order operation, and then you're here. Once you get here, you can see that you got an I squared there. Substitute that for a negative 1, and then combine your like terms. Combine like terms, and you end up here. 0 times 0 plus 0 is 0. 0 makes the equation true, see, because 0 equals 0. Therefore, it is a solution. This is a solution of the equation. Now, if you get a false statement again, you know that this is not a solution. 2i is not a solution of this equation. Okay, but I'm going to go ahead and skip that. I don't think I'm going to assign one of those problems. Okay, so don't worry about that. And move on to objective G, which is about quadratic equations with non-real solutions. Quadratic equations with non-real solutions. Well, all this means is that you're solving now. That's essentially what it means. Because remember that up until now we've been factoring, but we never, well, we did simplify a few times. I mean, we solved it a few times. But in this case, for this section, we are solving, okay? So officially for the first time we are solving, okay? I'm gonna work this one out because, let me see, let me fold my paper here. It is asking us to, yeah, it is asking us to, like, literally to solve for, and I'm just writing on my paper here, which is what you should do too. And there are different ways of factoring and solving, but you already know that. In this case, we only have two terms. Make sure you that your first step, whenever you have more than one term, is to look at the different terms and see if they have any common factors. Okay, that should be the first step. In this case, these are not common factors. Well, there aren't any common factors here. So you go ahead and simplify, solve for x. So what we need to do is, even though this looks like a quadratic equation, well, even though it is, you are not gonna use the you are not gonna use any of the methods that you learned to factor because you're missing a term. See, so this made it simpler. Okay, way simpler. Once you're missing one of the terms, either the middle one or the last one, then it should be easier to factor without using the to solve without using any of the factoring methods we learned. Okay, so the way we do that for this one, since we're missing a middle term there, we go ahead and solve for x. Watch here, add 9 to both sides. Okay, that gives me 4x squared equals, subtract. It's good that I cut myself there, because or else I'd be wondering what I did wrong. Now I divide both sides by 4. That's x squared on this side, and I have 9 over 4 on this side here. And now I can square both sides. This become, these two cancel out, these two order operations cancel out. Now I have x equals, square root of negative 9 over 4. Okay, so I'm right here now. For this square root, again, think about it as, and this is the way I would work it out, as being I squared times 9 over 4. Okay, if I can think about it that way, I can pull the I out of the radical sign, because now I know that this is an I square, okay? And this is a perfect square now. So just move it outside the radical sign. Leave 9/4 inside. Simplify if you can. Well, in this case, I can see that the 9 is a perfect square, and 4 is also perfect square. Okay. So rewrite that as 3 squared. 3 times 3, and then 2 squared. And I can move those outside the radical sign now. Okay, that's 3 over 2 times I. Okay, and the radical sign goes away. So this is my solution. Well, yeah, my the value for x, except for I missed the positive and negative values here. Okay, so in this case, when you're solving, remember that before we only use the positive values for square roots. Well, when you're solving, you really need 2 answers, because you don't know which answer is going to be the solution for the equation, okay, or for the expression. So in this case, you would rewrite this as x equals 3 over 2i, and or this case is or x equals negative 3 over 2i. Okay, so those will be the 2 answers there. Okay, all right, so yeah, those are the 2 answers there, and you will need to go back to your equation and see if which one was correct. Okay. Well, in this case, what did they say? The solutions are, we check. Okay, let's see if they did anything else. I don't think they did, but let's see. No, I don't think they did. Anyway, we are not gonna get that deep into it, I don't think. Now, the only other thing you need to be familiar with is the quadratic formula, okay? In this case, we think about the coefficients of the terms as A, B, and C. See, coefficient 1 is A is, hold on, there. Coefficient 1 here is my A, so A equals 1. For B is -4, include the signs, okay? For C is +13, okay? And then for the equation, if you don't already know it, okay, it is, I'm just gonna write it here, x equals negative b, b plus or negative, I'm just gonna write it, okay, there you go, square root of b squared minus 4 times a times b times c, I mean, times 2 times a, okay? So that's the quadratic formula, okay, in case you didn't know that. And I don't think I'm gonna assign you one of this unless I provide you with the formula. So if you don't already know it, go ahead and have it by your side and use it. And in the test, I'll give it to you. If I give you one of these problems, okay, I will provide for you. You don't have to memorize it, even though it would be nice if you did. Because in algebra, they don't give it to you. They don't give you the formula. You're supposed to already know it, okay? And then you substitute values. And then perform the operations, and you should get 2 answers. From now, yeah, whenever you're solving again, you should get 2 answers now. Okay? We've been skipping that. We've been skipping the negative answers. However, this time we're solving, we need 2 answers. Okay. So the solutions are 2 plus 3i or 2 minus 3i. Okay. Same thing for this one, except for the values for A, B, and C are different. A, B, and C. Plug them into the equation. I will give it to you, so you have it handy whenever you do your assignments. And then I will provide it to you in the test, and I will give it to you if I have one of those included in the test. Okay. And then for and then just perform the operations, and your answer should be either a positive or a negative answer, or both. In this case, in this case the answer is -5/4 plus square root of 3/4i, or -5/4 minus square root of 3/4i. Okay, so 2 different answers. Right? And that's the end of this section, and that's the end of this video too. So I will see you on the next one. Okay.